Okay, so in today's lecture, we will talk about programmatic thinking. We will learn how to break tasks into smaller steps. We will understand some concepts related to programming, and that will help, or usually programmers usually use when they do programming. And finally, we will practice and we will see how we can think systematically, the way that in a way that we can interact with the computer as effective as we can. Maybe we can wait for 2 minutes until more students can join, since today this is the first lecture of the week. I'm gonna stop for just 2 minutes, and we can start in a moment. Okay. So in this week, we will touch briefly on certain topics. So we will not dive deeply into coding. We will not start into JavaScript yet, but we will just talk briefly on some topics that you can build up later on. You can use as a base to later build on when we start the coding material. So programmatic thinking or computing thinking is a way of thinking to solve problems, because computers, they use logic. They don't use or think like we do. We think in two ways. We think intuitively and we think logically. We have creative mind, we have logical mind, but computers, they understand logic. So we need to think the way that the computers think in order to interact with the software or the computer effectively. Now, this includes learning some concepts that usually developers use. And these concepts are those: decomposition, abstraction, algorithm design, iteration, and debugging. So we will talk about all of those today with simple examples and everyday examples. So you don't need to memorize them, or you don't need to understand, let's say, their definition one by one. But usually what programmers do is they apply these principles by nature. So you will see a programmer do decomposition, do abstraction, write an algorithm, and do iteration and do debugging by nature. Unless there's a very complex problem, a very huge problem, then they go back to the principles, they apply them one by one in very concrete manner. But for now, since we will start our programming journey, our learning journey, so we need to touch base, or we need to learn the basics of these principles in order to start creating this programming mindset, especially if you don't have a background in computer science. So the first one is decomposition, which is basically breaking problems into smaller parts. So sometimes you would face a very complex problem, a very huge problem. So you need to break it down into smaller pieces and start focusing on working on solving each smaller part one by one. The second one, abstraction. We hide unnecessary details, and we focus on relevant details, or the main or the core points. We will see examples for each next. The third one, algorithm design. I think you have already heard of algorithms, or maybe in the introductory videos you also learned about algorithms. It's basically logical steps. So you need to create logical steps, because this is how the computer thinks. The computer understand, you give the program or the computer tasks, and the computer do these tasks. The fourth one is iteration, which basically repeating steps. So this is a huge part, or let's say a significant part of programming. Usually, we write code, but we need to repeat doing this code. And there is, of course, tools for that provided by programming languages. And finally, debugging, which is fixing errors. And now, in everyday life, so we will start simple. In everyday life, we practice logical thinking, of course, because we have, as we have seen in the beginning, we have logical mind, as also we all know. So, but we usually we do this by nature. So we don't write algorithms, or we don't say, okay, I'm gonna think logically to make a coffee, for instance. But I do certain or I follow certain logic. I apply certain steps when I make the coffee. I add water, I add coffee, I place the cup, plug in, and turn on. Similarly, getting ready in the morning, I wake up, brush teeth, eat breakfast, get dressed, and go to work. Now, when you deal with the software, you need to define these steps and write them. So you will do this by nature. So for now, you need to understand that this is what we do as developers. Later on, when we start on simple tasks, you would require to write algorithms. But later on, when you have more experience, you would do this by nature for smaller tasks. You will feel like you can do the algorithm in your mind, like the way you prepare for coffee, for instance. For complex code, usually they, as I mentioned earlier, they do separate decomposition, separate algorithm design, and so on. Now, what is decomposition? It's basically we have a big problem, and we need to make or divide it into smaller problems in order to make solving the big problem easier. So for instance, if we have a task to clean the room, instead of, let's say we have a robot and we need the robot to clean the room, instead of maybe when let's say we are trying to develop the robot to clean the room, we can start by knowing what parts the robot will do when it comes when we asked the robot to clean the room. So it's gonna be organizing the clutter first, dust the surfaces, clean the floor, dispose of trash. So as you can see, you've done decomposition, and you done it because you need it. Um, we start from a big problem. We need to define these problems, and we did that by breaking down the complex or the big problem into smaller parts. Um, this is it, basically. We have an exercise here. For instance, try to break down the task of planning a vacation. So I'll give you 1 minute or 2 minutes. Can you try to maybe break down this task into smaller parts, like what I've done here? Um, can you see the difficulty, or let's say the way things are done when it comes to decomposition? So I'll give you 1 minute, and we can come back and see if anyone wants to share um, their decomposition. All right. Anyone wants to share? Or maybe a comment on this, on the task itself? Yes.
I can share.
Yes, please.
Yeah, first, I will try to figure out what's our budget for the vacation.
Okay.
Second, I would like to know what we like to do or see in the vacation,
Mm-hmm.
and then based on that, next step would be to locate a location of places that have that's on the budget and things that we can do, and then I will list it out because sometimes with the budget we have, some of the things won't be done or we need to increase, and we can decrease the things we can do. So I just set up like a list of the destinations, their budgets and activities they have, and from that on I would choose the one that's like the closest to the budget, with the most activity of the required activity that my family wants, and I will stick with that.
Okay, sounds great. Thank you for sharing. Thank you all also for contribution. So as you can see, there's similarities in the decomposition, but there's differences as well. And that also what happens with developers. So we solve tasks in a different way to solve the same problem. And usually it's because of the background, it's because of the technology that the developer know, for instance, the way they think, okay, here it's mentioned cost, which is also very important when it comes to deciding how to divide the problem. Uh, okay, here we have a more detailed one. Thank you all for your contributions. Um, so that's it about decomposition. Next, we have abstraction. This is the second feature or the second principle of logical thinking, of computing thinking. Abstraction is basically simplifying a task by hiding unnecessary details. So we focus on the big picture. We don't need the small details. It's not the opposite of decomposition. So here we have a big problem and we make smaller parts of that big problem. Here we hide the small details and focus in the main points. So for instance, um, here we have an example of Audi. So we have a car. From the Audi brand, and we need to build a database, for instance, to store this car, for instance, or to store multiple Audi cars that we have. So we can abstract this layer by storing a car, or having a car table, because Audi is a car, or we are storing cars, and we add an interface to stop and start the car, which is basically functionality for all of the Audis that we have. So as you can see, from Audi to up to car here, this is abstraction. You hide the unnecessary details, which is those, and the name of the brand. We're not interested in this example in the name, for instance, but we need to abstract, and this abstraction is basically focus on what is important. Now, this is in databases. But abstraction could be applied to software, could be applied to any tech related, or also or full stack development related uh, uh, field or section. But in real life, we have this example, for instance. If you have a task of driving a car from one destination to another destination. So if you want to do the tasks for driving for this task, I mean to break down the smaller tasks out of this task, which is driving a car. So you could say, I go outside, I open the door, I sit on the I sit on the chair, I start driving, or I start turning left, turning right, and all that. But if you sometimes want to do abstraction, you hide unnecessary details. So you don't need all the details. Instead, you just define an abstracted view of the problem, which is basically driving a car to the destination. So driving a car to the destination, this is abstraction of the problem. You can solve it on the tech that you have based on the abstraction you made. And this kind of abstraction, this applies to any car, this applies to any destination. So that's the benefit of abstraction, is that you can generalize your solution to the parts that you're trying to solve, to the inner parts that you're trying to solve, like the car here and the destination. So we have another example here. We have different people that we want to store in a database. We have different also jobs. So we abstract that by having person, and we add the first name, the last name, skills, and job. Also for the job type, also we define, instead of name of jobs, we do company, position, salary, and we can later on add or allow the user to add their job, for instance, their name. So you shift from the details to the big picture. Okay, any questions so far?
So basically, with the abstraction is just figure out your way around the problem from one thing to another thing without having each and every detail, like with the problem breakdown with the composition, right?
Yes, so it's basically hiding. So the key word here is hiding. So you basically hide small details and abstract the problem to be generalized later. This is abstraction. We will see that this in action. Um, and as I told you again, I personally do not like memorize these concepts or apply them apply them directly or explicitly. Rather, with time, with practice, you will absorb these concepts and just apply them when you write your code. This is what we will do in this course. This is what you will feel like at the end of the course. You will write code and you will do the composition. You will do abstraction by nature. Because of the assignments that we give you, you will practice coding, and you would have a big problem. You will start with um, like dividing the problem into smaller parts. You will start making abstraction. If, let's say, um, you have a task to make a travel agency, for instance, and there's different destinations, or you are provided, for instance, with destinations, and you're provided with a vacation plan to make. So you hide unnecessary details, which is where this destination is, how the transportation is done, like train and car and all that. Instead of, for instance, we asked you to make the user select between car, a train, or a plane. So you abstract these into a transportation, for instance. So you hide unnecessary details and focus on the core point, and you generalize your solution. So this is abstraction. I hope that answers your question, Samuel. The next,
Thank you.
for sure, is algorithm design. Um, Algorithms are a set of rules uh, that we write or develop to solve a problem. Um, this is an example in everyday life, making pancake, for instance. This is, let's say, a simple algorithm, but there is some complexity here. It's not complex, of course, but some kind of, we have feedback here. So you measure pancake mix, you add the water, you mix, you mix everything together. If it was too thick, then you go back and add water again. If it's spreadable, then you can just start doing the pancakes. So this is an algorithm. Now, in everyday life, again, we don't try this down. We might try it, for instance, when we do recipes, we follow algorithm. But in code, sometimes you need to write algorithm because the code is complex and you cannot remember everything in your code. You cannot remember, for instance, if it's too thick, should I add water or not? You might forget this. Of course, here you will not because it's simple. But when you have complex code, when you have a very like a lot of sent statements for like those, and we would have a bigger flow chart, you would forget certain behavior of your code. You would miss also certain variables and so on. And you would also sometimes the problem is too complex and you cannot solve it by just looking at it. You need to write down the flow chart, write down the steps in order to solve it. Now, again, in the course, at the beginning, you might need to write algorithms like small ones like these, or a little bit more complex with flowcharts. But at the end, you would do this by nature, of course, like you do the pancakes. But if you faced a much difficult problem, you need again to go back to the flowcharts. And the reason for that, computers follow exact instructions, or in code, they're called statements. They do not infer. So the computer doesn't know if it's too thick, I should add water, but we know. And that's why we need to give exact instructions. Now we have an exercise here. If you want, also if anyone wants to contribute, we can have 1 minute. The exercise is asking directions to reach school or work. You can do it in a flow chart on any software on the internet, or you can just do it on paper. You can do it by writing. Like you don't need to do flowchart if you want. You can just write sentences. For now, anything is fine. It's just for practice and see how do you find programmatical thinking? How do you find thinking like the computers understand? So we will have 2 minutes, and we will come back with your contributions. Okay. So we have someone on the chat. Find miles from home to school, calculate time, need to reach destination, determine which route is best, and then take route that best suits needs. That's very good. Anyone else wants to share maybe a flow chart, maybe maybe if you've done on paper, that would be great as a practice in the beginning. But anyway, you got the idea. Yes, please.
Hi.
Great.
So I figured out something like the picture we have here. So at first we, I don't know, get ready, take our stuff, and then we use the maps to find the best route. And then we start our route, and then it comes to two different ways. Either, for example, it's an I don't know, it's not traffic or easygoing, but sometimes there's a traffic, there's a, I don't know, accident or something. So I'll check, for example, my maps again and find another route.
Yeah, that's great. Thank you. So it's logical steps. Now, the difference between decomposition and algorithms, decomposition is we are dividing into smaller parts. That's the main objective, the main point. Here, we are writing certain steps. So in this example, you can see you can go back. You can have conditionals, as you will see, if conditions. You will use the tools that the software allow you to use, that the programming language allow us to use in order to solve our problem, as we will see today and also in the future. Thank you also for your contribution. Okay. Now the next principle is iteration. So iteration is repeating a process. Now in real life, it's not much like there's not much a clear example of repeating, but maybe stirring. If you have sugar, for instance, if you want to dissolve the sugar in water, so you keep stirring. So stirring is in the computer mindset. Stirring is one step or one functionality, which is stirring once. But in the computer mindset, you have to make iteration. You have to keep stirring. You have to do the stirring again and again and again. Because in the computer mindset, the operation has a limit. It do something. So in the computer mindset, let's say if a robot is stirring, so the robot would make a circle. That's one stir. And if we want the robot to keep stirring, we need to make the code or iterable. We need to tell the robot, okay, stir 10 times, for instance. So the robot will do stirring 10 times and so on. Now, this is in real life. In code, this is a simple example that is very common in code. We usually add variables in lists. Don't worry about the terminology for now of the code, but just imagine you have just a list or a collection of numbers. So we have 1, 2, 3, 4, 5, 6. We can iterate, and we need to print. We need to print these numbers one by one on the screen. So what we can do, we can just type print the first item, print the second item, print the third item, and so on. So we would type print according to the numbers we have. We have 6 numbers, so we need to write the statement 6 times. Or we can do iteration, which is the for loop. Of course, we will talk about that in details in the future. For loop allows you to iterate over lists. So we need to write print once, and the for loop would repeat the process according to the numbers of the items we have. So each value will be printed once on the screen with repeating. So this is okay, we will talk about conditionals, but we have conditionals and we have iteration. Those two concepts are also very important parts or part of the computational thinking or software thinking. The developer thinking. So just a quick review: we have decomposition, we have big problem, small problems, we have abstraction, we have algorithms, we have iteration, and finally, we have debugging. Now, debugging is fixing errors, and unfortunately, this step is unavoidable. So usually, developers, they spend a lot of time just fixing errors. But fortunately, we have a lot of tools that help us in detecting errors and in fixing errors as well. So you would see this screen a lot. You will see this. You would see that, okay, there's something wrong on the code that I wrote. What I've done wrong? The debugger or the IDE that you will use will tell you that what kind of error it is, which line that that error was in, and so on. yeah, here in this example, befriending errors. So it's unavoidable, as I told you. Example is in real life, you have you want to toast a bread, but you forgot to plug in the toaster. So when you try to click the toaster, it will not work. So the debugging part is plug in toaster, basically. So the word is a bit it's not common, but it's very common in the in the development field. But it's just when you hear debugging, it's just basically fixing errors. Okay, now we go on into some also related concepts. We have pseudocode. So when I asked you to write an algorithm, some of you wrote something on the chat. So this is pseudocode rather than an algorithm. Usually algorithms are written in flowcharts, as we have seen, like as rectangles and cubes and so on. But pseudocode is written in plain English, in plain language. And it's written usually beside the code or before writing the code in order to write the code, in order to remember what you want to write. So for instance, we have a task here of making tea. So yeah, so sorry. So making tea here, the pseudocode is basically add water, heat water, add tea, pour hot water. Now, pseudocode, the meaning of pseudocode is basically a code, not a code, a language or statements, collection of statements that describe your code. This is what a pseudocode is. You can write whatever you want. In the editor, as we will learn, we can add comments, and we can add them in JavaScript, for instance, we can add 2 slashes. And as you can see in the editor, we have gray color here. So these are not read by the compiler. They're just for us. They're just for the human, not for the computer. And this is just a way to understand your code when you share your code, for instance. And also, its first use is basically to prepare yourself to write your code. You design an algorithm, you do abstraction, you do composition, you do all what we have mentioned. But in pseudocode, we do this. We write pseudocode before before we start developing. We have an exercise, write pseudocode for turning on a TV. Any contributions? Turning on TV, plug in TV, pick up remote, put batteries, and so on, push power button. That's good. Now you write this, you do what we have learned already, and then you write your pseudocode here, for instance, at the top of the IDE, and then next you start writing your code. So the pseudocode is written at the top or at the bottom, for instance, or on a different page if you want. But it just is just reference for you to write your code in a clear manner. Now, from my experience, usually students, they skip much of what we talked about today. Some students, let's say, but it's good practice if you learn or if you start building your own way of doing things. How you want to do abstraction, how you want to do decomposition, how you want to let's say do debugging. Okay, we will learn that, but most importantly, how you want to write your pseudocode. When we give you a task, you start thinking from programmatically and so on, but breaking the task, decomposition, abstraction, and writing your pseudocode before diving into code will help you a lot when you start writing your code. Okay, another contribution we have: check the table, check the TV, press the button, wait a few seconds, and display TV is on. Okay, thank you all for your contributions. Now, another part, I talked about iteration. but here we have also conditionals. So in logical thinking, we have conditions, we have conditionals, which is a logical way of making decisions. It's basically if then. So if, for instance, you define a condition first. If the condition is met, then do certain code. If the condition is not met, do another code. Then finally, both should go to a certain part. So if we start from A, we go to F, we define a condition, we have true, false, first code, second code. If it's true, then do this code. If it's false, then do another code. So for instance, in real life, if it's raining, take an umbrella with you. If the kettle boils, pour the water. So that's it in real life. Now we have an exercise. Now write a conditional for deciding whether to eat at home or a restaurant. You can, for now, you can just write a sentence like this, but see the way of the computer works. This is how the computer, this is how you will interact with the computer when you write code. So I'll give you 1 minute and we will look at your contributions in a minute. All right. Okay, that's great answers. Those are great answers. If groceries, then eat home. If ingredients, then eat home. If favorite restaurant, eat at restaurant, and so on. As you can see, it's very simple, but at the same time, we're learning how the computer works, how the computer understands. If it's sunny, eat at the restaurant. If there's power to eat home, falls, eat at restaurant. Okay, very good answers. Now, this concept, beside iteration, are very important concepts. You will learn the code for that, of course, but but for now, just try to know that these are the ways, or one of the ways that we can interact with the computer. Now, common bugs, we talked about debugging, but there's some common bugs that is good to mention here. For instance, from our side, we have skipping steps. Sometimes we forget certain steps, and we will have undesired results because of that. Sometimes we do incorrect sequence. As you can see, as you have seen in the algorithms, for instance, we follow certain steps, certain sequence, sorry. And sometimes we write incorrect sequence, at least at the beginning of designing our algorithm. And sometimes we miss conditions because we write the wrong condition. So is it, for instance, if the alarm rings, turn off the switch? In this example, it's correct, of course. Let's say the condition itself, sometimes we write the wrong the condition. For instance, I want to turn off the switch, but not when the alarm rings. When, I don't know, something else happens. Of course, here it's correct, as I mentioned, but yeah, this is also one common bug that we face. Now we have three types of errors, of common errors as well. We have syntax errors. Now the code, in syntax errors, we basically use language that the software doesn't understand. So as you know, the programming language is called a language, so we should use certain grammar for that. And if we messed, or if we write a grammar that the computer doesn't understand, or the software, the compiler, sorry, doesn't understand, we will have a syntax errors. But fortunately, usually IDEs will tell you that there is an error. It's gonna tell you you can't write, for instance, this integer in this way because this is a rule in this language, and so on. Now we will talk, of course, a lot about debugging, but this is just an introduction. Another example here is runtime errors. So those happens when you execute the code. So sometimes you write your code, it looks good, but when you start compiling, when you start running the code, some error happens, and there is wide possibilities of the source of this error. Usually IDEs help us also in runtimes errors. For instance, sometimes it's a RAM issue, sometimes a size issue, sometimes when you run the program, you have assigned, for instance, a type of value for an integer that doesn't accept this value. For instance, you define a constant value, x, and you added number on that, number 5. But you later on try to change the value of the constant x. Now it's constant, so the constant value cannot be changed, but you try to change that in the code. So this is a runtime error, and the IDE or VS Code, for instance, the development development environment will tell you there is a runtime error. Finally, we have semantic errors, and they happen when you execute the code. It works, but you would have incorrect or unexpected results. So you would have, for instance, you write very simple algorithm to sum two numbers, x plus y. You entered 2, you entered 5, and the answer was 8 for some reason, not 7. Or you would have unexpected results. The answer was null, or the answer was undefined, for instance. So you know there is some problem in your code, and you try to fix that problem. Okay, now now this is a pseudocode, and usually, as I told you, we write pseudocode, and we write our code, or we write our code and we just write comments to pass our code to other developers. So this is called documentation. So doing all this, like doing decomposition, abstraction, iterating, defining conditionals, fixing errors and all that, then you write your pseudocode, then you jump from your pseudocode into code. So you start taking these steps one by one and try to make them code. Now, this requires that you know this language because, as I mentioned earlier, it's a language. So you need to know the grammar. You need to know how it's used. What are the concepts of this language? What are the way that this language is written? So in this course, we will learn JavaScript. This is my friend, and if you want it to be your friend, that's a very good friend, let's say. Now, JavaScript is a front-end language, is used in web browsers, and they call it the magic of front-end because it allows you to add interactivity to the front end. Now, but JavaScript is, as I told you, front-end language, so we cannot use it in databases on server side, but there is a way to use it on server side. So in this stack, in this course, we will use JavaScript all the way from front end to back end using Node.js. Now, I don't want to dive into more details, but we will learn JavaScript, and that's why we will start. Once we start the course officially, the first milestone is learning JavaScript. You won't see visuals yet. Once we start, you will understand this language. You will know how it works, what we can do with this language, what concepts we have, and so on. So for instance, we have for. Now for is iteration. It's written in this way. It's written for, you open bracket, you have 3 sections. They're separated by semicolons. This section has a certain job. This section has a certain job. This section has a certain job. You open bracket and you close bracket. Now this is called grammar. This is called syntax. You will learn all that during the first milestone. Okay. Now in the end, what we are trying to tell you in this lecture is that having a developer problem solving mindset. So first, you need to understand the problem fully. Then you have the tools to solve this problem, break down the problem into smaller tasks, smaller pieces, focus in what is important, abstraction, think step by step, logical steps, iteration, patience and precision with conditionals, and finally, fixing errors. Now, we have a real life example here of testing a new recipe. So imagine you have a recipe and you want to test that to make food out of this recipe. So the decomposition of that is basically you have ingredients, you have tools that you will use, you have the location, the kitchen. So I divided the problem. Now abstraction is that instead of, let's say I have a big closet of ingredients, I tell someone to bring the ingredients for me. So I focus on the word ingredients. Now I'm abstracting this problem. I'm telling someone else to solve it. So I'm not jumping into the details of each ingredient and so on. But then I have the recipe, or I try to refine the recipe, which is add this ingredient using this tool, put it on the stove, and so on. So I have logical steps to do that. And I do iteration because in my first try, the food wasn't good. So I try it one more time. Okay, this is after debugging. No, iteration here is, the example was stirring. So let's say we are stirring food. Now humans in everyday example, it's very straightforward, but in computer logic, we need to define a task and then tell the computer to do the task multiple times. Finally, we debug. If the food wasn't good first time, we fix the type of ingredients we make, or maybe the heat on the stove and so on. Then we run the code one more time until we have the correct or intended results. Okay, finally, we have a scenario. You are creating a morning routine for a robot. So write a pseudocode that include conditionals for the robot. So the morning routine is basically waking up. I don't know what people do in the morning, brushing teeth, breakfast, and so on. But I want you to do that in pseudocode. Inside that, add conditionals. For instance, add if statements, and also add iteration if you can. If you want to make the robot to do thing more than more than one time. So for this task, I'll give you 2 minutes, and we can come back with with your contributions. We have 5 minutes left, so we will do this fast. Okay.
For this pseudocode, is it more than just waking up, like performing the tasks of the morning, or do you want it to be just waking up?
It's basically a morning routine rather than just waking up. But what I want you is to add if statements and add iterations like this, basically. If you can add fors, and if
Okay.
you can add if statements here. But for a robot, in a morning routine. Okay, so we have if washing machine stops, take out clothes. If not, do not. Okay, that's good. So that's simple. But for a more complex problem, you need to use different statements. You will see that, okay, you use certain if statements, certain for loops, certain normal statements, and so on. So anyone who wants to share? Okay, wake up at 6 a.m. Check the weather for your users, put that on the screen so they can see that when they wake up. If it was a cloudy, prepare vitamin D. If it was sunny, play some music. That's very good. So you have two F statements here, then prepare the breakfast and tea. Now this is really good, and you can translate that into code. If alarm rings, wake up. If everyone at home is awake, ask them if they need coffee or tea. Give them coffee or tea. Ask their preference. Prepare the breakfast and serve. That's also very good. 6 a.m. ring alarm, else no alarm. Clean the room. Repeat every 5 hours. Okay, that's good. For loop. Mop the living room. Those are very good examples, and you can take this pseudocode and start writing code out of this. If alarm rings, wake up. If it's cold, turn on heat. Okay, thank you all for your contributions. Any questions about today? Because we have 1 minute left. I think I took the whole hour. Usually we finish 5 minutes earlier. Oh, yes, we will share the slides, and the recordings will be uploaded on YouTube. Okay, for the morning routine, usually, okay, we can start with saying that if alarm rings, wake up, else stay asleep. So here I stay asleep if the robot will stay asleep if it doesn't alarm. Now we start with a for loop after that, and we need to make, for instance, 3 meals a day. So we can say we open the for loop, and for 3 times. So I want to do iteration 3 times. And inside the for instance, I ask the hour. If hour is 12, make meal. After that, if hour is okay, it's in the morning. So if hour is 8, make meal. If hour is I don't know, 1, make meal. If hour is 5 or 6, make meal. We close the for loop. So it's a for loop, and then there's 3 if statements inside. Okay, maybe that's not a very clear answer. Okay, no, that's the wrong answer, actually. Never mind. But basically, it's just what in real life, the thing is, in real life, it's hard to write an example of that. But the robot, what would the robot do more than 1 time in the morning, for instance? So you start from there and you write a for statement from there. Okay, it's 101. We will learn about for loops. So for now, this is a good beginning. I hope that you all enjoyed the lecture, and see you next one.